Welcome to second session on pointers. In this, we will discuss how to manipulate the pointers. That means there are certain operations which are permitted. There are certain operations which you cannot perform on pointers. So those things you have to remember. You cannot do everything with the pointers. There are certain operations which are permitted. Only those permitted operations you have to do. So before getting into that specific topic, let us consider the memory requirements. Suppose if we declare integer a, float b, and integer star point 1, float star point 2. Now how much memory is required? And when the memory is allocated actually? In many books, this is not conveyed clearly. So if we consider this integer a and float b, the memory is allocated depends on the system compiler. Suppose if assuming that integer occupies 2 bytes, then 2 bytes will be reserved for integer and 4 bytes will be reserved for floating point, that is b. So for a 2 bytes, for b 4 bytes, that will be reserved, and that memory is allocated during compilation time. If we consider this one, integer star point 1, float star point 2, then how much memory is allocated? So when the memory is allocated, that's where you have to concentrate. When the memory is allocated, for these two variables also, memory is allocated during compilation time itself. And the amount of memory that is allocated is how much? Is it 2 or 4? How much memory is allocated for point 1? How much memory is allocated for point 2? So it depends on actually the address, but the amount of memory that is allocated is independent of the data type to which it is pointing. That means for both point 1 and point 2, same amount of memory is allocated. So if the address occupies 2 bytes, then for both point 1 and point 2, only 2 bytes is reserved. If the address occupies 4 bytes, then for both point 1 and point 2, the amount of memory that is allocated is 4 bytes. Okay, so it depends on the address, but the amount of memory that is allocated is independent of the data type to which it points. Okay, this is for pointer. Remember, don't get confused here. So you have pointer. So you have pointer which points to some other data type, So here we are discussing about the amount of memory that is allocated to this one, pointer. Amount of memory that is allocated to pointer. The amount of memory that is allocated to pointer. Okay, we are not discussing about the amount of memory that is allocated. So don't get confused. So this is different. So this is different. Okay, the amount of memory that is allocated for this one is independent of the data type. It depends on the address length. And the memory is allocated during compilation time. Whereas for this one, it depends on the data type. The data type to which this pointer is pointing. If it is pointing to integer, then it may occupy 2 bytes. If it is pointing to float, then it may occupy 4 bytes. And this memory can be allocated even during the runtime, or memory can be allocated dynamically for this one. We will discuss how to allocate the memory dynamically later. So for the pointer variable itself, the memory is allocated during compilation time, and the amount of memory that is allocated to a pointer variable, not to the variable to which it points. The amount of memory that is allocated to the pointer variable is same and is independent of data type. Operations that can be performed on pointers. What are the operations that can be performed on pointers? So if a pointer points to a data type, say data type 1, then whatever operations that can be performed on data type 1 can be performed on the values that pointer points to. Again, observe carefully here. Here we are discussing about in this statement we are discussing about the operation that can be performed on the data type to which the pointer is pointing. So if integer is pointing to if pointer is pointing to integer data type, then whatever the operation that can be performed on integers can be performed on the data that the pointer is pointing to. The operations that can be performed on the pointers themselves is limited. Note that pointer contains the address and they are whole numbers. The following operations can be performed on pointers. Remember, again I will repeat. So here these operations means the operations here are not about the data type to which it is pointing. So the operation that can be performed on the data to which it is pointing depends on the data type. Whereas the operation that can be performed on the pointer are limited. So these operations can be performed. You can increment pointers, decrement pointers. You can that means +1, +2, like something like that. Decrementation of pointers. Subtracting two pointers, adding an integer to pointers, These operations you can perform on pointers. Whereas operations that cannot be performed on pointers are multiplication, addition, division, remainder. Remember, addition of two pointers is also not permitted. You can add an integer to a pointer. So now what is that? Actually? That means, let me just again read out this one. So if here it is 124, so you can add an integer to a pointer. So you can add an integer means this is the address. You can add in integer 124 plus say 2. 124 plus 2, or you can write 124 minus 2. So like that you can do, but you cannot multiply. Why? You cannot multiply. Why you cannot add? Why you cannot divide? Why you cannot find the remainder? Because of the problem with the overflow. The problem is overflow. Say they are the addresses. They will not be actually simple numbers like 124. So they will be addresses. Okay. So usually they will occupy all the bytes of that address. There will be large numbers. If you multiply, the multiplied value doesn't fit in within that address again, within that pointer, within the location of the pointer. That's why these operations are not permitted. So even addition of two pointers may result in overflow problem. Overflow means that the value doesn't fit within this one. So if the value that fits within this one is say some 32768, say approximately, okay, 32768, then if you add two such values, then it may not fit in that location. That's why these operations are not permitted. It's better you note down, take a snap, and remember these things. So accidentally we will try to perform different operations. So we cannot perform. These are the operations that can be and that cannot be performed on the pointer variable itself. Okay. So now different operations can be performed on this one depending on the data type of this one. If it is integer, you can perform division, remainder, etc. If it is float, you cannot perform remainder if it is float. So comparison operators. The following comparison operators are permitted on pointers. You can compare like this: equal to, not equal to, less than, greater than, less than, equal to, greater than, equal to. These comparison operators can be applied on pointer variables themselves. Note that the comparison is based on the value of the pointer, not the value to which it is pointing, based on the value of the pointer or the address to which it is pointing. The address pointer contains the address. That address can be compared. The values to which pointer points can be compared based on the data type of that value. Different types of pointers. This is only for information sake. So we'll not be using many of these things. The only things I think we should bother about nowadays is one is null pointer, generic pointer, and then dangling pointer. Apart from it, you can neglect the other things. So if you are not interested, you can skip this point also. Skip this part also. Okay. So these are the different types of pointers. First one is null pointer. We will use this null pointer. Null pointer is a pointer which points to nothing. It is usually used when we work with the data structures like linked lists. We will discuss in the last module the linked list. Then we will see. So null pointer means it is pointing to nothing. So when pointer cannot be assigned any value, it is made to point to null. When pointer is initialized, it can be made to point to null. So that means diagrammatically it is represented like this. Null pointer, it points to nothing. Diagrammatically it is represented like this. Null pointer points to nothing. So usually null pointer indicates the end of the what is called as linked list. So I can try to draw it. It may take some time. So linked list, you can say the list formed by what are called as links. That's why it is called as linked list. List means collection of items. You have this collection of items. All these rectangles represent collection of items. And you can see here links. That's why it is called as linked list. So in the case of the linked list, the last element points to null, which is generally represented like this, something like an earth symbol, linked list. So null pointer means it points to nothing. It points to nothing. That means it is the end of the linked list. Wild pointer, a pointer which is not initialized and which is not made to point to anything, is called as wild pointer. It is not pointing to anything. It is not made to point to anything. This is called as wild pointer. Wild. We don't know to which memory location it points to. It can point to anything. That's why it is called as wild pointer. Wild. Something which doesn't have any control. So we don't know exactly to which it points. In that case, it is called as wild pointer. Wild pointer. Near pointer. These are applicable with old systems actually. Nowadays we are not interested in near pointer, far pointer, huge pointer, etc. But maybe for information's sake we will discuss. So there are some old concepts which are used with 16-bit architectures. So that means 16-bit machines. So they are near far huge pointers. Near far huge pointers. Nowadays we have 64-bit architectures. So these things don't apply now. The pointer which can point to only 64 KB of data is known as near pointer. So in 16-bit architecture, the data is divided into what are called as segments. Data is divided into what are called as segments. So if you have multiple segments, say multiple segments, if you have multiple segments, the near pointer can point to only one data segment. It cannot point to multiple data segments. Near pointer can point to only one data segment. So that's why it is called as near. Its range is limited. The size of near pointer is usually 2 bytes. Far pointer and huge pointer. The pointers which can access the entire memory. Both can access the entire memory. But huge pointer is more flexible. We are not getting into the details of why it is flexible, but both can point to entire memory. And the size is 4 bytes. In the case of far and near, both are of type. Far and huge, both are of type 4 bytes. Both are of size 4 bytes. So you can declare like this. Dangling pointer. You should be careful about this dangling pointer. Usually while doing programs on linked list, you should be careful. The pointer which is pointing to something which no longer exists. Okay, it may existed a few seconds back, but it is no longer exists. So that for the understanding that one, you should understand that we can allocate the memory, we can release the memory. There are two functions which are related to allocation of the memory. Malloc is used to allocate the memory and free is used to release the memory. We will discuss this malloc and free along with the linked list. But for the time being, just remember, malloc is a function which is used to allocate the memory. Free is a function which results in release of the memory. Now suppose you have a pointer. Okay. You have a pointer. Pointer is, say this is the pointer. It is pointing to something. This memory is allocated. This is pointing to something. And you call free on this one. That means if call free on this one, this is released. So that means this pointer is pointing to something which is no longer meaningful. That is called as dangling pointer. So here you can see pointer pointing and that memory is freed. In that case, it is dangling pointer. Generic pointer or general pointer, you can say. Pointer of type void is called a generic pointer. Pointer of type void is called a generic pointer. So as such, no value is associated with void. So to use a generic pointer, we have to make it to point to data of some other type. And the advantage of this generic pointer is it can point to anything. So if you have say void star PV, not integer, not float, void star PV, then this PV can be made to point to any data type. Made to point to any data type. That's why it is called as generic pointer. That's why it is called a generic pointer. And this is one of the advanced concepts. Probably in this course we will not discuss these generic pointers. Generic pointers. Okay. Maybe I will try to add at some other point of time. The advanced concepts, many advanced concepts in C language. So this is called as generic pointer. Generic pointer, which can point to any data. So that is regarding the pointers. So always come to the point. So this is regarding the pointers. I will discuss examples through programs. That will be better rather than discussing it theoretically. But remember, here we are keeping it simple only. These are only the two sessions, the previous one and this one. These are only the two sessions I have added as part of the pointers module. Okay, you try to be strong on pointers. So if you are strong, then you can do lot of things. Few things we will do in the end module, last module. Maybe you will do more in this data structures part. Thank you.